Now, in order to go ahead and plug in for X, we need to choose a neighborhood. So the neighborhood we're going to be focusing on here is a neighborhood called Cherry Hill. And Cherry Hill is actually kind of interesting because they have an outrageously high rate of kids who are chronically absent. And Cherry Hill, they have about 50.8% of their high school kids don't show up to school regularly. Now, this is really high, and so what we want to do is we want to use this to go ahead and predict exactly what's happening there in terms of the violent crime rates. So in order to do this, we need to go ahead and take our value here, and we're going to go ahead and plug it in for X. So I'm going to predict the violent crime rate, y hat, by using negative 9.19, once again my y-intercept, plus 0.8038 times that times the absence rate of 50.8. The regression line itself is designed to use the percentage without converting it to a decimal, which is really nice. Doing this and plugging in, then I get a violent crime rate of 31.64. We're just going to keep two decimal places for this example. And it's important to realize this is per 1,000 people, because that's how I set up my regression line. So we're predicting that Cherry Hill actually had a violent crime rate of about 31.64 violent crimes per 1,000 people, which is pretty high. Our question then is, were we accurate or not? And to answer that, we need to look at what actually happened. So, are we accurate? Well, it turns out that in Cherry Hill, the number of violent crimes per 1,000 people is only 23.5. So in reality, the violent crime number is actually lower than what we predicted. We can measure how accurate we are by calculating what's called a residual. A residual measures how far our observation is from our expectation. So it's our observation minus our expected value. This should look really familiar. It's the reason we've taken x minus x bar for means, or p hat minus p when we were doing proportions, or more recently, observed minus expected was exactly what we did whenever we did a chi-squared. So this residual concept has been with us for quite a while. To calculate the residual for a regression line, all I do is plug in my information. That is, my observed value is what actually happened, so 23.5, and I subtract off my expected value. My expected value is what I predicted, so 31.64. The value I get out of here will be, once again, the residual, or how far off I am. The important thing to notice here is that I get a negative residual, and I get a negative residual because my expectation was actually above what I observed happened, or, and I'm going to say that, my observed value is below my expectation.